Hello, so this is lesson 103 on volume. So you know how I love my definitions. So volume is the amount of space the object occupies. Sometimes you think of it as a three-dimensional object. How much stuff can it hold? So in other words, how big is if it has a length, a width, and a height? So that's what we're going to talk about. But let's review a minute. The first thing they ask is to measure baseboard molding. So if I had to measure my baseboards, I might take my tape measure. I would say, oh, maybe 12 inches on this wall, and maybe if I go to this wall, maybe it's 16 inches. If I come over here, maybe it's probably 12 again. And then I measure that wall, and then I'd add them all up, right? So in this room, I would measure 4 feet this way, 4 feet this way, 4 feet this way, and 4 feet this way. And I would just add them up, right? Because I'm just making a line. If I unfolded that room, it would be all one line, and it would be 4 plus 4 plus 4 plus 4, or 16 feet, okay? So think about it kind of like putting a fence around something. You're just finding a linear distance. You're not multiplying anything, you're adding it up. So this would be measured as 16 feet for my example of baseboard molding. Okay, now they want you to find the area of a rug. Okay, I could do that. So here's the rug that's going to go in my room. Uh-oh, it's too big. Maybe it's going to go in a different room. So this rug is 5 feet, so 1, 2, 3, 4, 5, by 6 feet, okay? So it's kind of a small little rug, but I can count. Let's pretend like each one of these lines is a foot apart. So I can count how many little boxes that are 1 foot square in each of my, in my rug. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I don't want to do all that. Can I just say that I have 6 5s or 5 6s? 5 times 6? So in this case, I have 30, but it's not just feet because I'm multiplying. Each one of those is a square, right? So I'm going to say 30 square feet. Okay, I can also write 30 feet square. The little 2 is up high and goes at the end. Okay, it doesn't go before. And that just means I'm squaring the feet, not the 30, okay? So that means I'm talking about something in 2 dimensions, area. Okay, now I'm going to talk about volume. So I've made myself my room again. Got a little sloppy on this one, sorry. And maybe I'm measuring how much air can be in a room. So I'm going to measure the length, the width, and the height all together, and I can see how many boxes. That's going to take a little bit more explanation, but that's what we're going to be working on right now. In this case, it would be measured in feet times feet times feet equals cubic feet, or cubic feet, or cubic feet. Either way, however you want to write it. If you do use your little cube sign, make sure it's at the end and up high. It should be a little bit smaller. Mine's a little big. Okay. So let's move on to example 2. And we're going to use some Legos to figure this part out. So we're going to be talking about volume, 3 dimensions, length, width, and height. Okay, so this is my area rug, right? So let's give myself maybe a little bit more. So what would the area of this be? Let's say each of those is a centimeter, we'll pretend. So it'd be 2 centimeters by 3 centimeters. So it'd be 6 square centimeters. Do I have 6 squares? 1, 2, 3, 4, 5, 6. Yes. So my area rug right now is 6 square centimeters. Well, let's say that I want to measure, I don't know, milk or something that I could put in a box. So I'm going to leave this and I'm going to add on another layer. So add that, and I'll add a white one, and a pink one, and a white one, and a pink one, and a white one. Okay, so how many do I have now? So my bottom layer is still 6 because I didn't take anything away. And 2 times 3 is 6. I have 6 little squares on my second layer. So how many squares do I have all together? How many cubes? Oh, I have 6 on this layer and 6 on this layer. So I have 12 altogether, don't I? So 12 cubic centimeters. What would happen if, let's use this color, I had another layer on there? What would happen then? And this part isn't in the book, but just so you know. Okay, so I have 6 and 6 and 6. So I have 6 plus 6 plus 6. Do I have 6 times 3? Yeah. So I have 18 cubes, right? So there's 6, there's 6, and there's 6. So I put them all together. I can figure that out with my length, my width, and then my height was 3. Okay, so that's kind of the Lego idea. If you notice, when I had, oops, if I can get it back together. If I had my solid like this, all I had to really do was count the top and see how many layers I had, right? So I have 6 cubes on the top, and I have 3 layers, so that makes it easy. I can do it from the side too in this case. I don't know if I can I take it this way and show you guys? Probably not, sorry. But you could turn it and then you'd have a slightly different angle on things. But you're always going to measure your length, your width, and your height. Excuse me. Okay, so that's my Lego math. I've got my first row, my second row, and then if I turn it, and if you look in the book, you can kind of see there, if you look at it from the side, they have 1 row here, 1 row behind it, and 1 row behind it. There's 4 in that first row, so I'm going to assume, because it's a rectangular solid, that there's 4 in the next row and 4 in the next row, right? So I can say 2 times 2 is 4, and then I've got 3 rows, so 4 times 3 is 12. So I get the same answer, whichever way I do it. Okay, easy peasy. Example 3, they gave you the bottom row, and then they just told you how tall the next row was. So it was, the length was 2, the width was 4, and the height was 3. So 2 times 4 is 8, times 3 is 24. Each of those was a centimeter. So centimeter times centimeter times centimeter. I have 3 of those that I'm multiplying. So I get my cubic centimeters. So I can write my answer either 24 cubic centimeters, or I can write 24 cm3, or I can write cubic centimeters. That's not quite so common, but you see it, okay? Let's see, what was I going to tell you? I think that was it. So you could count the cubes on the bottom row, and you see that you have 8 of them. Let's go back to the book for a minute. So if I count these, I've got 8 cubes, and it tells me, since each of these is an inch, that I have 3 rows. So 8 times 3 is 24. Even if I didn't know that, they give me the dimensions. So length times width times height. Oh, I know what I was going to tell you. I never remember whether this is length or this is length. It kind of depends on how you turn your block. Pick one. This is kind of sideways, so I usually take length as the one facing me. Mrs. Snyder may tell you something different. Oh, look, length, width, and height. So, but if I turn that, it might be slightly different. So it's not critical that you get that particular thing correct. Just make what works for you, okay? Example 4. They want Emma is going to keep quilts in this cardboard box, right? So she has a box, and they give me the dimensions. It's 36 inches long, 24 inches wide, and 24 inches high. Okay, so I'm going to assume, since that's 36, that that's going to be 36. because it's a rectangle, right? If that's 24, that's going to be 24. And then they tell me that it's 24 high, right? So they want to figure out just the top because she wants to put just fabric on the top of that box. So if you only have 2 dimensions, do you remember what that's called? Area, right? Okay, so she's going to find the area at the top, the length times the width, 36 times 24, and they're both in inches. So 36 times 24 is 864. And I have inches times inches, so I have inches squared, and that's my units. And that's the units for area. Now she wants to know how big it is inside, right? So is it big enough to hold all of her fabric? So volume is length times width times height. So length times width, I got up here. I don't have to do it again. It's 864 square inches. And then my height is 24 inches. So when I multiply 864 times 24, I get 20,736. Inches squared times inches is inches cubed, right? Because that's inches times inches, and then you have another times inches, cubic inches, right? Okay, example 5, the trick with this one is they're estimating. So let me read you the problem. As Dion ate breakfast, he estimated the volume of the cereal box. What is the approximate volume of the box? Okay, so he's just taking kind of educated guesses about this. Trick with this is you round the numbers before you multiply. So 12 and an eighth rounds to 12. Remember, 4/8 would be halfway, and that's smaller than halfway. 7 and 7/8 rounds to 8 because 7/8 is really close to that next number. And 2 and 3/4 rounds to 3 because 3/4 is bigger than 2/4, right? Length times width times height. 8 times 3 times 12. So my height was 12. Length, width, height. Multiply all those together. I get 288 cubic inches, or cubic inches, or cubic inches. That's terrible handwriting. There you go. Right? Does that make sense? Okay. Now comes the tricky part. They're going to ask you about surface area. So I'm not going to measure the inside of the box. I want to find the areas of all the faces of this rectangular solid. That looks more complicated. And this gets a little confusing. So they gave me this cereal box and they said 12 and an 1/8 inch high, 8 inches, and then 3 inches on that side. Go back and look at that box. So 8 inches there. Can you see? Yeah, 3 inches there and 12 inches high. Okay. So they want to know the total area of the outside of the Saxon-O's cereal box. So he decided to cut open the box and he laid it flat. He noticed that the creases divided the figure into 6 rectangles. Each rectangle is one of the panels or the faces of the box. So he estimated the area of each rectangle and then added those 6 areas. So we're going to do that. Okay, so let's take this away for a minute. Okay, so I have Dion's cereal box, right? It's falling apart cereal box. Okay, so there's face 1, face 2, face 3, face 4, face 5, and face 6. So a cube has 6 sides, and so does a rectangular solid. So now I have my box that I cut open. I'm going to lay it nice and flat. And I notice that if that's 3 inches, and this is a rectangle, that's going to be 3 inches. Oh, no, my pen doesn't work. That's going to be 3 inches. You know that's an inch sign. And I notice if that's 12 inches, that's going to be 12 inches. 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 And that's going to be 12 inches. Oh, that's crazy. Huh. Okay. What about, I don't know these, do I? Well, if I fold it back up, I see that this side and this side are the same. So if this side's 8 inches, this is going to be 8 inches. This is going to be 8 inches. And this is going to be 8 inches. Huh. Okay, well, that tells me that this is going to be 8. This is going to be 8. What about these little guys right here? Let's fold it back up and take a look and see which one it's the same as. Oh, it's the same as 3 inches. Oops, I'm upside down, sorry. Can't figure out how to get it right side up. Okay, so I know that that's 3 inches. That's 3 inches. That's 3 inches. That's 3 inches. This one's 8, and this one's 8. So I've labeled all my dimensions, haven't I? Oops, except for that one. That one's 3 inches. Okay, so now I can easily calculate the area of each of these rectangles. So this one's length is 8, width is 3. So what's that one? 24, right? Let's do this one. 3 times 12, 36. We'll put the units in a minute. 8 times 12. What's 8 times 11 is 88 plus another 8, 96. Oh, is this the same as this? 8 times 12? Oh, it is. Look at that. And is that the same as that? 3 times 12? And is that the same as that? 24? Cool deal. Okay. So now I have my areas for all of my faces. So I can say 36, 36, 96 and 96, and 24 and 24. Did I get all of them? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes, indeed I did. Okay, so I could just add all those up. And if you notice, because it's a rectangle, these two are going to be the same, these two are going to be the same, and these two are going to be the same. So I'm always going to have on a rectangle 3 pairs. So each pair is the same area, okay? Because I'm not multiplying, I'm just adding, and they're in square inches. I'll just put that for all of them. I noticed that if I add all those up, I get 312 square inches. Make sense? It's easier seeing it laid out flat, and you'll be doing more complicated shapes next year. But just remember that when you have a box, it has 6 sides, so you want to find the area of each side, okay? And you know that some of them are the same. Every single time I get this dimension, it's going to be 8 inches, right? This is 8, this is 8, this is 8, this is 8, this is 8. So you have to kind of think about what's the same when you're doing surface area. I'll see if I can find a good video for you on that one, because that one's kind of complicated. On the lesson practice, remember that if it says about or a reasonable estimate, round those numbers before you multiply. Okay, good job, you guys. Good luck with this.